This is Britt Caswell with another example video. In this video, I'm covering example 5 from section 3-5 in the SavvasRealize Algebra 2 textbook. So what we're doing in this example is we are looking at how to solve polynomial equations. So here we are with a polynomial. If you notice, there's an equal sign here and it's kind of ugly. So the first thing we always want to do is we want to get all of our expressions onto one side, or sorry, all of our terms onto one side, and set the entire equation equal to 0. So to do that, I'm just going to kind of do this all at once. Alright, I'm going to subtract 3x cubed. Alright, I'm going to subtract the 8x squared, and I'm going to subtract the 1. And so what that's going to do is that's going to produce a polynomial that just has everything on one side of the equal sign. So 2x cubed plus negative 3x cubed is negative x cubed. In terms of my x squared, 5x squared minus 8x squared is negative 3x squared. And then I have a minus 3x and a minus 1. And I could set that equal to 0. So now that we've done that, now we would need to go about finding our real or imaginary zeros. So just a reminder, because this has an exponent of 3, what that's telling us is that we're looking for 3 zeros. Alright, so that degree of the polynomial tells us how many zeros or how many solutions there should be. So in the end, I'm looking for 3 separate x's. Okay. Now if I pop this bad boy into Desmos, alright, I'm going to get a graph. It looks roughly like this. And it's crossing at negative 1 on the x-axis. So one of my zeros is negative 1. So what I'm going to do is I'm going to use synthetic division in order to divide that 0 out of the function. So I put my negative 1 outside of the synthetic division house, and I fill in my coefficients. And remember, if I was missing a term, like if there wasn't a square term, I would need to put in a 0 here, okay? So I drop down my negative 1. Negative 1 times negative 1 is positive 1. Negative 1 times negative 2 is a positive 2. Negative 1 times negative 1 is a positive 1, giving me a remainder of 0. And remember, that's a good check to make sure that you get that remainder of 0. So this polynomial now looks like x plus 1, because you flip the sign on that one, times negative x squared minus 2x minus 1. Now because this is not factorable, okay, which I know it's not factorable because this only crossed the x-axis once, what I'm going to do is I'm going to use the quadratic formula or completing the square in order to solve it. So what I'm doing here is I'm setting up my quadratic formula. Sorry, it's a little squished right there. Alright, now my b value is negative 2. My a value is negative 1. And my c value is negative 1. So as I go to solve this, a negative negative 2 turns to a positive 2. And 2 times negative 1 is negative 2. And then I tend to take this radical out to the side. So negative 2 squared is 4. A negative times a negative times a negative will produce a negative. And 4 times 1 is 4. So this is a square root of 0. So the square root of 0 is 0. Oh, interesting. So I get x equals 2 plus or minus 0. It doesn't matter if I add 0 or subtract 0. That's still 2. So I get x equals -1. So on these are both -1, because when I did the quadratic formula, that's the number that I got. So that's interesting, because this polynomial is essentially just turning into f of x equals x plus 1 times x plus 1 times x plus 1, or you could say it's x plus 1 squared. And I think that's kind of cool. Or I'm sorry, not squared, cubed. So there are our 3 solutions, which is really just the same thing 3 times. Alright, so let's go ahead and let's try this bad boy. So again, to start out, we want to move everything onto the same side of the equal sign. Now this one has a squared term on it, so I'm just going to move everything to the right. So I'm going to subtract x cubed from each side. I'm going to add 7x to each side. And I'm going to subtract 6 from each side. So this turns into 0 equals, the x cubes cancel, and I get 5x squared plus 5x minus 30. So this expression turned into a quadratic. And that's kind of nice. Now I'm going to try to simplify this to see if it gets a little easier. Now if you notice, 5, 5, and 30, those are they all have a greatest common factor of 5, so I'm going to pull that 5 out. So I get x squared plus x minus 6. And this can be factored with the double bubble. Okay? So I know I'm going to have an x and an x. I drop down my plus. To get a -6, I have to have opposite signs. So this one has to be a negative so that they're opposites. And then I have to ask myself, what multiplies to make 6 that subtracts to make 1? Well, that's going to be 3 and 2. So now to get my zeros, now that I have it in factored form, I'm going to take each of these expressions with x, and I'm going to set them equal to 0. Okay, that's the zero product property. So this one turns into x equals -3, because I'm subtracting 3 from each side. And this one I add 2 to each side, and I get x equals 2. I'm just going to clean up that 3 because it's a little ugly. There we go. So this only had 2 solutions, and it occurred at -3 and 2. So let's go ahead and let's try one more, just for the heck of it. So I don't like having this negative stuff, so I'm going to go ahead and add x cubed to each side. And I'm going to add 2x to each side. And so the polynomial that I end up with is x to the 4th plus x cubed plus 2x squared plus 2x. And that's going to be equal to 0. So then just looking at this, do you see how there's like a pattern in the coefficients? This is probably going to turn into some kind of a factoring by grouping situation. So I'm going to go ahead and do that. Alright, so I'm going to break this up into 2 sets of parentheses with a plus between them. And I'm going to factor out their greatest common factor. Okay, I'm going to put this here to remind you guys I'm factoring by grouping. And I know to do this because I have 4 terms, and I saw that there was a pattern with my coefficients, and recognized that I might need to do it. Okay. So here, my greatest common factor between x to the 3rd and x to the 4th is x to the 3rd. So this is going to turn into x to the 3rd times x plus 1. And then in my second set of parentheses, my greatest common factor is a 2x, because that's what can be divided out of both of those. So this also turns into a x plus 1. And then with factoring by grouping, right, I'm going to say, well, I have the stuff that I factored out here in one parenthesis, and then the parentheses that was copied. Alright, so now we're looking for more ways that I could factor. So on this orange one, I see that both the terms have an x. So I'm going to factor out the greatest common factor out of this part here. So x cubed and 2x, those have a common factor of x. So if I divide that out, this turns into x squared plus 2. And I still have my x plus 1 and my equal 0. Now x squared plus 2, that is not factorable any further. So this is going to produce imaginary solutions. And that's okay. So because this is x to the 4th, okay, original polynomial has x to the 4th, that didn't go away, I know I'm going to have 4 solutions, okay? And so to find these solutions, I'm going to take each of these and set them equal to 0. So I have x equals 0, x squared plus 2 equals 0, and x plus 1 equals 0. So my first solution is there right away. My second solution, right, I don't have a linear term, so I could just go right for it here. So I get x squared equals -2. And I could take the square root of each side and put my plus or minus, so I get that x equals plus or minus. The negative comes out in the form of an I, and I can't take the square root of 2, so it says the square root of 2. So this is actually 2 solutions. One where it's a positive I root 2, and one where it's a negative I root 2. And then for this last one, I subtract 1 from each side, and I get x equals -1. So this here is my set of solutions. So there you guys have it. That is a little bit of arithmetic about how to solve some polynomial equations. Until next time.